Hi everyone, this is Team 24. We will start by showing you a small demo of our game.
Okay, so it's a 1 minute bike racing game in which you have to avoid hitting incoming traffic and roadblocks. On pressing the up key, the game starts. So as you can see in the demo that there is incoming traffic and on hitting the traffic the score gets deducted. On the left corner of the screen you have scorecard displayed. So as you hit any enemy or the roadblock, the score gets deducted. And with the time the score keeps on incrementing. On the right side of the screen, the timer is displayed. So let's have a look at the various design patterns implemented in our project. We'll first demonstrate the state pattern. Now the game currently is in stationary state, and as soon as I press the up key, the game goes into the running state. Now as you can see, the game is in running state, and as soon as I collide with any of the incoming vehicles or the roadblocks, the game goes into the collision state. From the collision state, the game goes back into the stationary state and comes into the running state if and only if an up key is pressed. Now, the game reaches to the finish state when the timer value reaches 1 minute. So let's see what happens when the timer value reaches 1 minute. So as you can see over here, the game gets over after 1 minute and the final score is displayed at the end of 1 minute. So we can see the state interface over here and 4 states implementing the state interface. Here bike player or the B player is our context class. So let's see the 3 methods that we have implemented in the state interface. The timeover method checks that if the value of timer is 1 minute, the game should reach finish state. And in the collide method, we are checking that if the bike player collides with any of the roadblock or incoming vehicle, the game should reach into the collision state. And in check key press method, we check that which key on the keyboard is pressed to control the game and the bike player. Now let's switch over to the second design pattern, that is the strategy pattern. So here we are trying to implement incoming traffic behavior through strategy pattern. We have used 2 different strategies to define the movement of incoming traffic vehicle. First is the vertical movement and second is the vertical along with horizontal. So let's see the functionality in the game now. So as you can see, the enemies are coming in vertically and some of the enemies are moving horizontally as well along with the vertical movement. So this is what we are trying to achieve through the strategy pattern.
Let's talk about the third design pattern, decorator. We have used decorative or the wrapper pattern to dynamically add the behavior of deducting the score based on the collision of enemy vehicle or the roadblock. So as you can see in the diagram, we have defined the score interface with a method deduct score which keeps the track of deducting the score based on the collision with which the bike gets struck. So every time the decorator classes are wrapped along the concrete score class to decorate the deduction in the current score of the game. Let's have a demo of this decorator. So whenever a bike collides with a roadblock, some score is deducted, which is much larger than the collision of enemy vehicle. We achieve this behavior using the decorative pattern.
Okay, next we'll look at the observer pattern implemented in our game. As you know, the observer pattern has a subject and multiple observers, one-to-many relationship. In our game, it is one subject and one observer. It could have been more observers as well. So The time actor is the subject which implements the subject interface. It has methods like attach, detach, and notify observers. The attach and detach method can be used by the observers or the observers to register or unregister or to attach or detach themselves from the subject from receiving notifications. The time actor class has multiple functions. First is it keeps a count of the time. The second is it displays the time on the game. And the third is, since it's a subject, if the time of 1 minute is reached, it sends out a notification or it notifies the observers, which is in our case the bike player, saying that the time of 1 minute is reached and we should end the game. The bike player in turn, then the update method of the bike player is called, since it's an observer and it has an update method. The bike player then, on receiving a notification that 1 minute has reached, it is going to change the state of the bike to the game end state, and the game ends. Now let's go ahead and look at how this is implemented in our actual working of the game. Okay, we'll just go ahead and look at how the observer pattern is implemented in our game. Right now, it's reaching near to 1 minute. Once the time of 1 minute is reached, the game is going to be over. It's going to display a game over message. So here you see the game over message is displayed. How that worked is the time actor class here, on reaching a time of 1 minute, it notified the observer, which is the bike class, saying that the game should be set to get finished state, and here the bike observer class sets its state to set get finished state or the finish state, and the game is stopped and the game over message is displayed. So again, once the time of 1 minute reached, uh, the time actor class called the notify observer method of all the registered observers. In this case, it was just one observer, which is the bike class. Uh, on the observer, the time actor class, which is the subject, called the update method. So the bike actor class had functionality written in the update method saying that when this update method is called, you set the state of the game to finish state and you display the game over message, which is what happened here. So that's it.
So hope you liked the game and thank you for watching our demo video.